Nothing to lose on number 8 here. Remember we talked about reciprocals. That's your answer. Can anybody explain to me why that's the answer? Why, Connor? Why is that the answer?
Because it's negative, you would flip it just like.
Yep. Notice I never said when it's negative we flip it to the bottom. I just said when it's negative we flip it to its opposite or to its reciprocal. So if my negative is in the denominator, well now it's got to end up in the numerator. If the negative is in the numerator, it's got to end up in the denominator. Okay? All right, 9. Number 9 is very similar to number 8. We're going to have 1 over x to the negative 4. 1 over x to the power negative 4. Brian, what do you think? X to the 4th. X to the 4th. Cool? All right, number 10. Now we're getting a little more meat on the bones here. And I have 2 over m to the negative 2nd n to the negative 4th. Okay, now here's how I'm going to solve this problem. I'm going to break it down. Oftentimes in years past, when I break it down, people think it's a little bit more work than is necessary. Totally fine with that. I'm just trying to teach it to you now. Any shortcuts that you find throughout the process, I don't care that you do them. Does that make sense? So notice I have a 2, and what's underneath that 2? We're breaking it all up. So it's going to be 2 over 1. Because if I'm just looking at the 2 is just by itself. Then we're going to have 1 over m to the negative 2nd, and we're going to have 1 over n to the negative 4th. Are we all okay with that? All I do is I just broke this problem down. I didn't change anything. I just literally separated all the different pieces out. Okay? Now, this one and this one have to do what? They have to flip. So do we agree that this is really going to become m squared over 1? And this one's going to become n to the 4th over what?
1.
Okay, now, I'm just going to combine by multiplying straight across. So I'm going to end up with 2 m squared n to the 4th over 1, which I actually have to write the over 1? No. The reason I'm breaking these apart, though, y'all, is because I want you to be able to see and identify what everything looks like. If you just look at it all as one piece, it's hard to interpret the different variables and the different exponents. Okay, try number 11, and then we'll move on to our homework, and we'll keep doing some together. All right, so 11, we're going to have 5 over r squared. We're going to call that t to the negative 4th. 5 over r squared t to the negative 4th. Got it?
Oh, no, I was just going to ask, what's the second one? It's not an R, is it?
It's a t, yeah.
Oh.
And it might not be a t, that's just what I'm going with since we know it's not an r.
Students and teachers, pardon the interruption. Teachers, Ms. Noon just sent out today's bell schedule for the future. I will let you know that we are working on the bells. Please follow that schedule with or without bells. We will have bells shortly. Thank you.
So you know how we haven't had bells the whole year? From now on, we're only having 4-minute passing periods instead of 6-minute passing periods. Okay? And we're going to go through the normal schedule that was last year. So instead of getting out of here at 9:22, we'll get out of here at 9:25 now. Does that make sense? I'm sorry, 9:24. Not 9:25, 9:24. So every class is adding 2 minutes back to the day. That's all it is. That's good for us. That means we'll probably do more challenges now that we have 2 more minutes. So, all right. So here's what I got for this one. 5 t to the 4th over r squared. Okay, let me break it down for you. 5 over what? 1. 1 over r squared, and then 1 over t to the negative 4th. 5 over 1, we're good with that one. R squared, nothing needs to be changed there. Negative 4, we got to flip this to t to the positive 4 over 1, which becomes 5 t to the 4th over r squared. Yeah? Brian, what's up? I saw your hand up.
So r squared is not r over 2.
It's not what?
R over 2. It's 1 over 2.
Yeah, because it's just on the bottom, but it's not a negative exponent. If it's not a negative exponent, we don't care. We're okay with it being there. All right, let me go ahead and go to the homework real quick. I'm going to get started with you guys on the homework. I know we're down to our last 10 minutes of class, but I know that this is a weird concept. I know that it's a little bit different. So I just want to make sure that we feel as comfortable as possible with it before I just cut you loose, okay?
Do we do all the questions?
Yep, so there are 29 total questions. But as you can see, some of them are super, super simple. And with them being super, super simple, I don't want to undermine or neglect some of these pieces. All right, so the only difference is now, instead of looking at variables, we have numbers involved. Okay, number 1, 16 to the 0th power is what? 1. Right here, I've got 4 to the negative 2nd power. So if I were to write out 4 to the negative 2nd, we really know it's going to become 1 over 4 squared. Can we agree with that? Can you tell me what 4 squared is?
Yes.
What is it? So here's what I want your answer to look like. 1 over 16. The reason on the previous problems we weren't finishing them out, we were leaving them as x to the 4th, is because we don't know what x is. But when we know what the actual value is, then I want you to see it all the way through. Does that make sense? You also have a calculator. So even if you have something to the 11th power, you can still do it. It's not that difficult. All right, number 3.
1 to the 27, or 1 over 27.
Beautiful. Well done. Let me backtrack on that. Stone is absolutely correct. Let me show you how we got to that process. 3 to the negative 3rd. Right? It stopped. Perfect. Thanks for letting me know, Brian. Which is really going to become 1 over 3 to the 3rd. And we know that 3 to the 3rd is 27, so the answer is 1 over 27. Are we cool with that?
Yes.
All right. I feel like you guys are pretty good with the rest of those. Let's jump down to 5 here. We're jumping down to 5. Again, I'm recording this on the video, so if you need to go back and look at these, you can. I have a negative in the denominator, which means that it has to go to where? The top, the numerator. So now I'm going to end up with 2 to the 5th power. Can we figure out what 2 to the 5th power is? Well, 4, 8, 16 to 32? Or am I off on that?
Yeah, 32.
So you just write 32. All right, I want to look at 6 now. 6 gets a little bit more crazy. Not in a bad way, just a little bit more crazy. I have 4 over 4 to the negative 3rd. If I rewrite that, I end up with 4 to the 3rd over 4. Are we all okay with that? Can anybody tell me what 4 to the 3rd is? You have a calculator. Connor?
64.
64. Okay, Charger. If I give you 64 over 4, what does that want you to do to it? Simplify. And when I say simplify, he wants you to divide it. Do we agree? In your calculator, do 64 divided by 4. that's the answer I'm looking for. I do not want you leaving it at 64 divided by 4. I want you seeing it through to get me to 16. Do we understand? You can. We've only got about 6 minutes left, though, so if you just want to hang tight.
It's literally on 1%, so.
But it's up to you, man. Your choice. Are we okay there? Anybody want to take a guess what number 7 is?
1.
3.
3. Because it's 3 times 1, which becomes 3. Okay, do we feel decent with these? Alright, any more on these 8, 9, 10, 11, 12 that you just see and you think, holy crap, I have no idea how to do it? Because if not, I'm going to scroll down and give you the same option. Look at that second page. What's up, Madison?
Number
14?
14.
Okay, let me scroll down.
Is it just saying the same thing, just like the base is a negative?
Yeah, so basically what we'll get to those. Yeah, so all of the only reason it's in there is because they want you to multiply that, and anything to the 0th power is still going to be 1. So this one would just be 1. This one would be 1 times 5. Does that make sense? It's just putting it in the parentheses because of the negative to show that it's attached to that problem. That's all it's doing. But yeah, it's the same exact thing. Okay, we're still good there? Alright, what about the second page? Notice how we're back on the variables now. Back to the variables now. In my opinion, the variables will probably be a little bit easier because you don't have to do as much math. You're just literally moving things up and down. Feel okay?
Yeah.
Alright, awesome. I'm going to check on our guys on the computer, see if they're okay.